June 6, 1944, 0530 hours, Omaha Beach, Normandy. Through the morning mist and chaos of D-Day, German observation posts witnessed something that defied every held-about assumption amphibious warfare. Massive concrete structures were appearing on the horizon, floating toward the French coast like prehistoric monsters rising from the depths. These weren't ships. They weren't landing craft. They were harbors, complete harbors sailing across the English Channel under their own power. Oburst Hinrich Weber, commanding the 352nd Infantry Division's coastal artillery, pressed his field glasses against his eyes with trembling hands. What he saw through the smoke and spray challenged everything German military doctrine taught about seaborne invasion. The Americans and British weren't just landing troops on beaches. They were bringing their own ports with them. Floating concrete piers stretched nearly a mile into the choppy waters. Massive steel roadways connected floating platforms that rose and fell with the tides. Ships were already unloading directly onto these artificial harbors as if they were permanent installations that had existed for decades. The mathematical impossibility of what Weber witnessed would haunt German commanders for the remainder of the war. In the space of hours, the Allies had constructed harbor facilities that exceeded the capacity of most French ports. These weren't temporary expedients or makeshift solutions. These were engineered marvels that represented industrial planning on a scale that German logistics experts had never conceived possible. But the story of how floating harbors came to shatter German expectations began not on the beaches of Normandy, but in the conference rooms of Whitehall 2 years earlier, where a former journalist turned prime minister would utter words that seemed to border on fantasy. Winston Churchill, facing the grim reality that capturing a major port would be nearly impossible against fortified German defenses, declared to his staff in May 1942, "If we cannot capture a harbor, we must bring one with us." The room fell silent. Admiral Lord Louis Mountbatten, Chief of Combined Operations, exchanged glances with his engineering staff. The idea sounded like something from a Jules Verne novel. Harbors were permanent installations built over years, requiring massive foundations anchored to bedrock. They didn't float. They certainly didn't sail across oceans. Yet Churchill wasn't joking. He was deadly serious about solving what appeared to be an unsolvable problem. German coastal defenses had turned every major port from Norway to Spain into impregnable fortresses. The raid on Dieppe in August 1942 had demonstrated the catastrophic cost of attempting to capture a defended harbor directly. Of the 6,000 Allied troops who landed, fewer than 2,400 returned. The lesson was clear. Any invasion of occupied Europe would require massive quantities of supplies flowing through port facilities. But those very facilities were too heavily defended to capture intact. The mathematical requirements were staggering. Military planners calculated that supporting a 1,000,000-man army in France would require unloading 12,000 tons of supplies daily. A single Liberty ship carried approximately 10,000 tons. Even if the Allies could somehow capture a major port like Cherbourg or Calais, German demolition teams would destroy the facilities before retreating. Rebuilding would take months that the invasion force didn't have. Churchill's seemingly impossible directive launched the most ambitious engineering project of the Second World War. Within weeks of his declaration, teams of British engineers, naval architects, and construction specialists were working around the clock on designs that existed nowhere in human experience. They weren't just building harbors. They were reinventing the very concept of what a harbor could be. The project received the code name Mulberry, chosen apparently at random from a list of approved operation names. But there was nothing random about the scale of what Mulberry represented. 2 complete artificial harbors would be constructed in British shipyards, towed across the English Channel, and assembled off the Norman coast within days of the initial landings. Each harbor would be capable of handling more cargo than most peacetime ports managed monthly. The engineering challenges seemed insurmountable. Harbors required protection from waves and storms. They needed deep water approaches for large ships. They demanded stable platforms for unloading heavy equipment. Most critically, they had to accommodate tidal ranges that could exceed 20 feet along the Norman coast. How do you build a structure that can handle such conditions while remaining mobile enough to be towed across 100 miles of open ocean? The answer came from Hugh Ioris Hughes, a Welsh civil engineer who proposed something that had never been attempted in maritime history. Instead of fighting the tides, the harbor would work with them. Floating concrete caissons would rise and fall with the water level, connected by flexible steel roadways that could adjust to any tidal condition. Ships could dock at any stage of the tide, with cargo flowing continuously regardless of water levels. The concrete caissons themselves represented a marvel of wartime engineering. Each Phoenix unit, as they were designated, stood 7 stories tall and weighed up to 6,000 tons when complete. They were essentially hollow concrete boxes designed to be towed to Normandy while empty, then sunk in predetermined positions to form breakwaters and piers. The largest Phoenix caissons measured 200 feet long, 60 feet wide, and 60 feet high. When flooded, they would rest on the seabed, while their tops remained above even the highest tides. But concrete caissons alone couldn't create a functional harbor. The Mulberry design included floating steel platforms called bombardons for the outer breakwater, providing the initial wave protection. Whale roadways, articulated steel bridges that could flex with the waves, would connect the various components. Spud pierheads, floating platforms with adjustable legs, would serve as unloading points for ships of all sizes. The scale of construction required to build 2 complete Mulberry harbors strained British industrial capacity to its limits. Over 400 individual components had to be manufactured, each one requiring specialized construction techniques. The Phoenix caissons alone consumed more concrete than Britain had used for civilian construction in the previous year. Steel requirements exceeded what the Royal Navy needed for 2 battleships. Production began in earnest during the winter of 1943. Shipyards from Scotland to Cornwall worked on Mulberry components. The Thames estuary became a staging area for the massive concrete caissons. Coastal communities watched in amazement as structures larger than apartment buildings floated past their windows, heading for assembly areas where the artificial harbors would be fitted together like enormous maritime jigsaw puzzles. Security surrounding the project was absolute. Workers signed agreements that prevented them from discussing their tasks, even with family members. Cover stories explained the massive concrete structures as experimental breakwaters for British ports. German intelligence, despite having agents throughout Britain, never grasped the true purpose of the construction they occasionally observed. The complexity, Mulberry harbour of the engineering extended far beyond the physical structures, was had to be designed for rapid assembly by men working under combat conditions. Every connection point was standardized. Assembly procedures were simplified to essential steps that could be completed by naval personnel with minimal specialized training. The entire harbor system was essentially a prefabricated kit that could be transported in pieces and assembled on location. Testing began in the spring of 1944, using scale models and prototype sections. Engineers discovered that their initial designs required constant modification. Wave patterns behaved differently than mathematical models predicted. Steel connections failed under unexpected stresses. Concrete caissons developed cracks when towed at speeds exceeding 3 knots. Each problem required solutions that had to be implemented across hundreds of components already under construction. The towing operations alone presented unprecedented challenges. Moving a 6,000-ton concrete structure across 100 miles of open ocean required tugboat power that didn't exist in peacetime. The Royal Navy assembled fleets of tugs for the operation, including vessels borrowed from civilian contractors, harbor authorities, and even salvage companies. Some Phoenix caissons required 4 powerful tugs working in coordination just to maintain steerage way in channel currents. Weather became the critical factor determining when Mulberry components could be moved. The concrete caissons could survive moderate seas, but the steel roadway sections were vulnerable to wave damage during extended towing operations. Meteorologists developed specialized forecasts predicting sea conditions along towing routes with accuracy that would determine whether the artificial harbors reached Normandy intact. As June 1944 approached, British ports filled with Mulberry components awaiting their moment. Portsmouth Harbour contained enough concrete and steel to build a small city. The Thames held floating roadways stretching for miles. Scotland's locks concealed bombardon breakwater sections that resembled sleeping sea monsters. Everything waited for the signal that operation in military history. The German would launch the most complex logistics perspective on Allied invasion preparations, focused entirely on traditional threats. Their intelligence assessments anticipated attacks on established ports or attempts to capture existing harbor facilities. Coastal fortifications were designed to repel frontal assaults on permanent installations. The possibility that the Allies might simply bypass the need for captured ports never seriously entered German strategic thinking. Field Marshal Erwin Rommel, commanding Army Group B responsible for coastal defense, had inspected the Atlantic Wall fortifications extensively throughout early 1944. His reports to Berlin emphasized the strength of port defenses and the impossibility of maintaining large armies without major harbor facilities. German doctrine held that any invasion force would be strangled by logistics within weeks unless they captured intact port infrastructure. This strategic blindness would prove catastrophic. German defensive planning assumed the Allies faced the same logistical constraints that limited German operations. The concept that an entire harbor could be manufactured, transported, and assembled under fire simply didn't exist within German military thinking. Their preparations focused on holding ports that the Allies would never need to capture. The morning of June 6th would shatter these assumptions completely. As German defenders struggled to contain the beach landings, they witnessed the beginning of an engineering miracle that would render their coastal fortress strategy obsolete. The floating harbors approaching through the morning mist represented more than innovative technology. They embodied a fundamental transformation in how industrial powers could project force across oceans. The first German observers to witness Mulberry construction in progress couldn't comprehend what they were seeing. Obergefreiter Klaus Richter, manning a coastal observation post near Arromanches, radioed his headquarters at 0847 hours with a report that his superiors initially dismissed as combat fatigue hallucination. Massive concrete structures approaching from the northeast. Estimate length 200 meters each. Moving under tow at approximately 4 knots. Purpose unknown. Request immediate clarification. The response from divisional headquarters was swift and dismissive. Concrete structures cannot move under tow. Report actual enemy movements. But Richter persisted, and within an hour, similar reports flooded German communication networks from observation posts along a 20-mile stretch of the Norman coast. Something unprecedented was happening off the landing beaches. By noon on D-Day, the scale of Allied logistics operations became undeniable. German artillery observers watched through their rangefinders as floating steel roadways extended from the beach toward deep water anchorages. Concrete caissons were being positioned with mathematical precision, their placement obviously planned months in advance. Most disturbing of all, cargo ships were already beginning to discharge directly onto these impossible floating piers. Oberst Werner von Kistowski, commanding the 716th Infantry Division's artillery regiment, attempted to target the artificial harbor construction with his remaining coastal batteries. His guns, designed to engage ships attempting to approach existing port facilities, found themselves facing targets they had never been trained to attack. How do you calculate firing solutions against a harbor that moves with the tides? How do you destroy something that appears to be both temporary and permanent simultaneously? The first concentrated German artillery barrage against Mulberry A, the American artificial harbor, occurred at 14:30 hours on June 7th. Von Kistowski's 155mm guns scored several direct hits on Phoenix caissons that were being positioned off Omaha Beach. The results stunned German observers. Instead of sinking or breaking apart, the massive concrete structures absorbed the impacts and continued functioning. The hollow design that allowed them to float also made them nearly impervious to conventional artillery fire. German naval intelligence had completely failed to anticipate Mulberry's existence, despite having nearly 2 years to detect the project. Captain zur See Friedrich Ruge, Rommel's naval advisor, had spent months analyzing Allied invasion preparations. His assessments consistently concluded that logistics limitations would prevent sustained operations without captured ports. The artificial harbors rendered his entire strategic analysis obsolete within hours of their appearance. The psychological impact on German defenders extended far beyond tactical surprise. These floating harbors represented industrial capacity operating on scales that challenged fundamental German assumptions about warfare. The Reich's military doctrine emphasized speed, efficiency, and making do with limited resources. The Allies were demonstrating something entirely different: the ability to overcome natural obstacles through sheer engineering audacity, backed by unlimited production capacity. Rommel himself witnessed Mulberry construction during his final inspection of Norman coastal defenses on June 8th. His aide-de-camp recorded the field marshal's reaction in diarrhea entry that survived the war. The enemy has brought their own harbors. This changes everything. Our entire defensive strategy assumed they would need weeks to establish adequate supply lines. They are unloading heavy equipment directly from ships, as if Normandy contained the port of Hamburg. The speed of Mulberry assembly shocked German engineers who understood construction timelines. Major Friedrich Körner, a civil engineer conscripted into coastal fortification work, calculated that the artificial harbors appearing off the beaches represented construction projects that should have required months to complete. Yet components were being connected and made operational within days of arrival. The implications for German defensive planning were catastrophic. German attempts to disrupt Mulberry operations through naval action proved equally futile. The Kriegsmarine's remaining destroyers and torpedo boats, based in Le Havre, launched desperate attacks against the artificial harbors during the nights of June 8th and 9th. They discovered that the floating installations were protected by naval firepower that exceeded the defenses of most permanent ports. Allied destroyers, cruisers, and battleships formed defensive screens around the Mulberry harbors that German naval forces couldn't penetrate. The E-boat attacks that did reach the artificial harbors found targets unlike anything they had been designed to engage. Torpedoes that struck Phoenix caissons simply exploded against concrete walls without causing significant damage. The modular design meant that even if individual components were damaged, the overall harbor system continued functioning. German naval doctrine had never contemplated attacking enemy ports that could absorb battle damage and continue operations. By June 10th, Mulberry harbors were handling cargo volumes that exceeded many peacetime commercial ports. German intelligence officers calculating Allied supply capacity discovered numbers that seemed impossible. The artificial harbors were unloading over 7,000 tons of supplies daily, more than the port of Cherbourg had handled during its best pre-war months. Yet these installations had been assembled from nothing in less than a week. The modular flexibility of Mulberry design proved equally demoralizing to German defenders. When storms on June 19th damaged sections of the American artificial harbor, replacement components appeared within days. The British Mulberry B at Arromanches expanded continuously, adding new piers and unloading platforms as tactical requirements changed. German coastal fortifications, by contrast, could only be repaired slowly using scarce resources transported through increasingly dangerous supply lines. German prisoners captured during the expanding beachhead battles provided Allied intelligence with insights into enemy morale that revealed Mulberry's psychological impact. Interrogation reports consistently mentioned German soldiers' amazement at the artificial harbors. Many expressed the belief that any nation capable of building floating ports possessed industrial resources beyond German comprehension. Obergefreiter Hans Müller, captured near Carentan on June 12th, told his interrogators that the artificial harbors convinced him the war was lost. We were told American industry was inefficient, that they couldn't match German engineering. Then we saw them sail complete harbors across the ocean and assemble them under fire. What can't they build? What can't they do? The strategic implications of successful Mulberry operations rippled through German high command throughout June 1944. Intelligence assessments that had predicted Allied logistics collapse within weeks of landing were revised repeatedly as the artificial harbors proved capable of sustaining ever larger forces. German defensive plans based on strangling the invasion through supply shortages became irrelevant. General der Artillerie Erich Marx, commanding the 84th Corps defending the Cotentin Peninsula, received regular briefings on Allied supply activities that painted an increasingly grim picture. His staff calculated that the artificial harbors were delivering more ammunition, fuel, and equipment than German forces in Normandy received through their increasingly disrupted rail network. The invaders were being supplied better than the defenders on their own territory. The technical sophistication of Mulberry Harbor operations impressed German engineers who understood the complexity of maritime construction. The whale roadways that connected floating platforms adjusted automatically to tidal changes that could exceed 20 feet. This flexibility allowed continuous cargo operations regardless of sea conditions, something that even permanent harbors struggled to achieve during severe weather. German naval architects studying captured Mulberry components through binoculars and recovered fragments realized they were engineering examining solutions, problems German to industry had never attempted to solve. The Phoenix caissons represented concrete construction techniques that exceeded anything built for the Atlantic Wall. The steel roadway sections demonstrated metallurgy and fabrication capabilities that German shipyards couldn't match even under peacetime conditions. The logistical mathematics of Mulberry operations overwhelmed German planning assumptions completely. Intelligence officers calculating Allied supply capacity discovered that the artificial harbors were supporting force levels that German doctrine claimed were impossible without major port facilities. The invasion had succeeded in bypassing the entire foundation of German coastal defense strategy through industrial innovation rather than military conquest. The psychological transformation of German military thinking accelerated as June progressed, and Mulberry operations expanded beyond initial projections. What had begun as tactical surprise evolved into strategic revolution that challenged core assumptions about industrial warfare. German commanders discovered they were fighting an enemy that could literally reshape the battlefield through engineering rather than conquest. Major General Wilhelm Falley, commanding the 91st Air Landing Division before his death on June 6th, had left behind planning documents that revealed German expectations about Allied supply limitations. His staff had calculated precise timelines for invasion collapse based on traditional logistics constraints. Without captured ports, the analysis concluded, Allied forces would exhaust their supplies within 10 days and face inevitable withdrawal. The artificial harbors rendered these calculations meaningless within hours of D-Day. The expansion of Mulberry Bay at Arromanches particularly astounded German observers monitoring Allied activities from inland positions. Each day brought new components arriving from England. Floating crane platforms appeared overnight. Additional pier sections extended the harbor's capacity for handling larger vessels. Most remarkably, the entire installation adapted continuously to changing operational requirements without interrupting cargo flow. Hauptmann Erich Zimmermann, an artillery observer positioned on the cliffs above Arromanches, maintained detailed logs of Mulberry construction that survived the war. His entries documented the systematic expansion of capabilities that German intelligence had deemed impossible. June 15th brought floating dry docks for ship repairs. June 18th saw fuel pipeline sections connecting directly to the artificial piers. By June 22nd, the harbor was handling tank landing ships, cargo vessels, and tankers simultaneously across multiple berths. The storm that struck Normandy from June 19th through 22nd provided the ultimate test of Mulberry engineering. German meteorologists had predicted that severe weather would cripple Allied supply operations and provide opportunities for counterattack. Instead, they witnessed artificial harbors weathering conditions that forced German coastal vessels to seek shelter in protected harbors. The American Mulberry A at Saint-Laurent suffered significant damage during the storm, but German observers noted that salvage operations began immediately. Within days, usable components were being transferred to reinforce the British installation at Arromanches. The modular design that had enabled rapid assembly now demonstrated its value for battlefield repair and reconfiguration. Captain Wilhelm Lewith, commanding U-boat operations from Brest, received intelligence reports about Mulberry Harbor defenses that revealed another dimension of Allied planning superiority. The artificial installations were protected by integrated air and sea defense systems that exceeded the firepower protecting many permanent naval bases. Fighter aircraft provided continuous cover. Destroyer escorts patrolled established patterns. Anti-aircraft batteries positioned on floating platforms created overlapping fields of fire. German submarine attacks against the artificial harbors proved futile, despite desperate attempts throughout June and July. The few U-boats that penetrated the defensive screens discovered that torpedoes designed for attacking individual ships were ineffective against dispersed harbor installations. Hitting a single Phoenix caisson or whale roadway section disrupted operations minimally while exposing submarines to overwhelming retaliation from escort vessels. The industrial implications of Mulberry construction gradually became clear to German technical intelligence as more information reached Berlin. These harbors represented manufacturing capabilities that exceeded anything achieved by German industry during the war's peak production years. The concrete alone, required for Phoenix caissons, would have consumed months of German cement production. The steel fabrication demanded precision welding on scales that German shipyards couldn't achieve. Dr. Fritz taught organization engineers, responsible wall construction for Atlantic, analyzed captured Mulberry components and reported findings that challenged German assumptions about Allied industrial capacity. The concrete mix used in Phoenix caissons exceeded German specifications for submarine pen construction. The steel alloys in whale roadway sections demonstrated metallurgy that German forces hadn't encountered in captured Allied equipment. The standardization evident throughout Mulberry design impressed German engineers accustomed to improvised solutions and resource shortages. Every connection point used identical fittings. All electrical systems operated on compatible voltages. Replacement components arriving from England fit perfectly into existing installations. This level of industrial coordination suggested planning capabilities that German production ministries had never achieved. Oburst Hinrich Weber, whose initial observations from Omaha Beach had documented German shock at artificial harbor operations, continued monitoring Allied logistics throughout June. His reports to Army Group B headquarters painted an increasingly desperate picture of German defensive prospects. The artificial harbors were expanding daily while German supply lines faced constant Allied air attack. Weber's staff calculated that Mulberry operations were unloading more supplies in a week than German forces in Normandy received monthly through their disrupted transportation network. The mathematics of attrition had reversed completely. The invaders possessed superior logistics, despite operating across 100 miles of ocean, while defenders struggled with supply shortages despite controlling interior lines of communication. The psychological warfare value of Mulberry harbors extended beyond their practical logistics function. German soldiers witnessing artificial harbor operations understood they faced enemies capable of engineering solutions to problems that German doctrine declared unsolvable. This technological superiority suggested industrial resources that rendered German resistance ultimately futile. Propaganda Minister Joseph Goebbels received regular intelligence briefings about Mulberry harbor operations that he struggled to present to the German public in favorable terms. Initial reports dismissed the artificial installations as desperate expedients that would fail under combat conditions. By July, the briefings acknowledged that Allied floating harbors were exceeding the capacity of major German ports while operating under constant threat of attack. The German Navy's technical assessment of Mulberry design principles revealed engineering approaches that challenged traditional maritime construction philosophy. German naval architects had always emphasized permanent installations built to withstand decades of use. The Allies had created temporary structures designed for rapid deployment that achieved superior operational capability through modular flexibility rather than massive construction. Vice Admiral Friedrich Ruge, Rommel's naval advisor, submitted a comprehensive analysis of Allied artificial harbor operations that reached Hitler's headquarters in late June. His report concluded that Mulberry represented a revolution in military engineering that rendered traditional coastal defense concepts obsolete. Any future German planning would need to account for enemies capable of creating their own port facilities wherever they chose to land. The modular construction principles demonstrated by Mulberry harbors influenced German thinking about defensive installations throughout the remainder of the war. If enemies could assemble complete harbors from prefabricated components, what other military capabilities might they deploy through similar methods? The artificial harbors suggested Allied industrial planning that anticipated problems German forces hadn't yet encountered. German prisoners captured during July fighting provided interrogators with insights into morale effects created by witnessing Mulberry operations. Soldiers consistently mentioned the artificial harbors as evidence of Allied technological superiority that made German victory impossible. Many expressed amazement that complete ports could be assembled from components transported across the English Channel. Feldwebel Otto Kruger, captured near St. Lo on July 18th, told American intelligence officers that the artificial harbors convinced his entire unit that Germany faced impossible odds. His testimony reflected attitudes documented throughout German prisoner interviews during the Normandy campaign. The floating ports represented capabilities beyond German comprehension or counter. The success of Mulberry harbor operations validated Allied strategic planning that had prioritized industrial innovation over traditional military approaches. Rather than accepting the constraints imposed by German coastal fortifications, Allied planners had engineered solutions that bypassed those constraints entirely. The artificial harbors demonstrated how industrial capacity could overcome geographic obstacles through technological innovation. Field Marshal Gerd von Rundstedt, commanding Army Group West, received intelligence summaries about Allied supply operations that documented the complete failure of German logistics warfare strategy. The artificial harbors were delivering tonnages that exceeded pre-war commercial traffic through major European ports. German forces faced enemies whose supply lines were more secure than their own, despite operating across hostile waters. The technical sophistication of Mulberry harbor operations impressed German naval officers who understood maritime engineering challenges. The floating platforms maintained stability in sea conditions that would force oars to suspend conventional HARBD operations. The flexible roadway connections accommodated tidal ranges without interrupting cargo flow. These capabilities exceeded anything achieved by permanent German port installations. German intelligence assessments of Mulberry construction timelines revealed Allied planning capabilities that German staff officers found difficult to comprehend. The artificial harbors had been designed, manufactured, and deployed in less time than German forces required to complete major fortification projects. This speed of execution suggested organizational efficiency that German military bureaucracy couldn't match. The strategic implications of successful artificial harbor operations rippled through German defensive planning for the remainder of the war. If the Allies could create their own ports wherever they chose to land, no coastline was truly defensible through traditional fortification methods. The Mulberry harbors had demonstrated that industrial innovation could overcome any geographic obstacle when backed by sufficient resources and planning. The mathematics of Mulberry cargo handling continued to astound German logistics officers throughout the summer of 1944. Daily tonnage figures exceeded anything German transportation networks achieved even during peacetime operations. The artificial harbors were supporting military operations on scales that German doctrine claimed required permanent port facilities with decades of development. By August 1944, German military assessments acknowledged that the artificial harbors had fundamentally altered the strategic situation in Western Europe. The floating ports had solved Allied logistics problems that German planners had assumed were unsolvable. This engineering triumph demonstrated industrial capabilities that German forces couldn't counter through traditional military means. The organizational complexity behind Mulberry operations revealed planning depths that staggered German intelligence analysts when they finally grasped the full scope of Allied preparation. Each artificial harbor required coordinating the movements of over 400 individual components across multiple staging areas, weather windows, and towing schedules that had to synchronize with the largest amphibious operation in history. German staff officers, accustomed to improvising solutions with limited resources, discovered they faced enemies who planned industrial logistics operations years in advance. General Major Max Pemsel, commanding the 7th Army's intelligence section, received detailed reports about Mulberry assembly procedures that challenged everything German doctrine taught about battlefield construction. Allied engineers were connecting massive steel and concrete components under combat conditions with precision that German peacetime construction projects rarely achieved. The Phoenix caissons were being positioned with mathematical accuracy despite enemy fire, rough seas, and tidal complications that should have made such work impossible. The most disturbing aspect of Mulberry operations wasn't their scale, but their apparent redundancy. German observers noted that Allied engineers had built backup systems for every critical harbor function. Multiple pier sections provided alternative unloading points. Spare whale roadway segments stood ready for immediate deployment. Even the tugboat fleets included reserve vessels capable of replacing damaged units within hours. This depth of preparation suggested resources so abundant that waste became a strategic advantage. Oberst Klaus Hamann, commanding coastal artillery near Courseulles, attempted to disrupt Mulberry construction through concentrated bombardment during the 3rd week of June. His 88mm guns achieved multiple direct hits on Phoenix caissons being positioned off the beach. Instead of the catastrophic damage German doctrine predicted, the hollow concrete structures absorbed the impacts and continued functioning. Allied repair crews appeared within hours, welding steel plates over shell holes and restoring full operational capability. The speed of battlefield adaptation displayed by Mulberry installations demoralized German defenders who understood engineering timelines. When storm damage on June 21st destroyed several whale roadway sections at the American harbor, replacement components arrived from England within 48 hours. German coastal fortifications, by contrast, required weeks to repair minor damage using materials transported through increasingly dangerous supply corridors. Captain zur See, Adolf Schnee, commanding the remnants of German naval forces at Le Havre, submitted reports that documented the complete failure of traditional naval warfare against artificial harbor installations. His torpedo boats scored direct hits on floating components that should have caused crippling damage. Instead, the modular design meant individual component losses barely affected overall harbor capacity. Destroying one Phoenix caisson left dozens of others functioning normally. The psychological warfare implications of Mulberry harbors extended far beyond their practical logistics value. German soldiers witnessing these engineering marvels understood they faced industrial opponents capable of reshaping reality itself through technological innovation. Traditional German military virtues of courage, discipline, and tactical skill seemed inadequate against enemies who could manufacture their own geographic advantages. Hauptmann Werner Pluskat, whose artillery battery overlooked Omaha Beach, maintained detailed observation logs that revealed the systematic expansion of artificial harbor capabilities throughout June and July. His entries documented floating crane platforms that could lift 50-ton tanks directly from ships to shore. Fuel pipelines snaked underwater from tankers to beach storage areas. Most remarkably, floating repair docks appeared capable of servicing damaged vessels without requiring their return to British ports. German naval intelligence had spent 2 years analyzing Allied invasion preparations without detecting the slightest hint of artificial harbor development. This intelligence failure represented more than tactical surprise. It revealed fundamental blindness to Allied industrial capabilities that operated on scales German planners couldn't conceive. The Reich's intelligence services had monitored British shipyards, steel production, and concrete manufacturing without recognizing the components of history's largest maritime engineering project. The standardization principles governing Mulberry construction particularly impressed German technical officers who understood manufacturing complexity. Every Phoenix caisson used identical pumping systems, electrical connections, and structural mounting points. Whale roadway sections featured universal coupling mechanisms that allowed infinite configuration possibilities. This level of industrial coordination required planning capabilities that German production ministries had never achieved even during peacetime. Obergefreiter Johann Weiss, captured during fighting near Villers-Bocage, provided American interrogators with insights into German soldier morale that revealed Mulberry's profound psychological impact. His unit had been told that Allied forces would collapse within days due to supply shortages. Instead, they witnessed artificial harbors expanding daily while German ammunition and fuel supplies dwindled. The contrast between Allied abundance and German scarcity convinced many soldiers that resistance was hopeless. The tidal engineering challenges overcome by Mulberry designers astounded German coastal defense experts who understood Norman maritime conditions. The artificial harbors functioned efficiently despite tidal ranges exceeding 20 feet and current patterns that varied hourly. Floating components rose and fell with water levels while maintaining operational capability. German permanent installations often suspended operations during extreme tidal conditions that barely affected Allied artificial harbors. Major Friedrich Körner, the civil engineer conscripted into Atlantic wall construction, calculated the concrete requirements for Phoenix caissons and discovered tonnages that exceeded Germany's entire monthly cement production. Each large caisson contained more concrete than major German fortification projects. Yet the Allies had manufactured dozens of these structures while simultaneously supporting global military operations. The industrial mathematics suggested resource depths that German planners found incomprehensible. The weather resistance demonstrated by Mulberry installations during the June 19th to 22nd storm provided the ultimate validation of Allied engineering superiority. German meteorological services had predicted that severe weather would cripple artificial harbor operations and create opportunities for counterattack. Instead, German observers witnessed floating structures weathering conditions that forced their own coastal vessels to seek protected anchorage. Korvettenkapitän Heinrich Hoffmann, commanding E-boat operations from Cherbourg, launched desperate attacks against Mulberry installations during late June, that revealed another dimension of Allied planning superiority. The artificial harbors were protected by integrated defense systems that exceeded the firepower protecting major German naval bases. Destroyer screens, aircraft patrols, and floating anti-aircraft batteries created overlapping defensive zones that German light forces couldn't penetrate. The few German naval attacks harbor installations reached artificial walls designed to engage that discovery operational components barely affected overall harbor capacity. German causing significant Wared targets damage, Theo did against Phoenix caissons, expel anything there. Torpedoes that nature individual struck of Mulberry design, concrete without unlike weapons, meant that destroying distribute doctrine ports that damage and battle had never could absorb. Enemy-aided attacking poured continue functioning. Dr. Naval Contemple, Ferdinandsche, consulting Germanmans, analyze assess GI evidentur assumptions about Allied industrial capabilities, technical and specifications that challenged fundamental captured Mulberry components and reported findings in steeled chemistry, concrete form, intelligence dway sections exceed. The metal knowledge ROA production Mulberry operations overwhelmed German planning. That German industrializations demonstrate use that German technical of sustain, the electrical systems revealed manufacturing precision in German tank institutes had mystical mathematics achieved, even couldn't match. The log assumptions throughout summer campaign that artificial harbors were delivering the Than German forces in. Intelligence officers calculating Allied supply capacity discovered through their disrupted rail more ammunition, fuel, and equipment daily. Normandy received weekly operations log network. The invasion had succeeded in reversing dating every defensivistical advantaged artificial hub captured during July, Viting consistently provided. Germanors, as evidence of Allied technological superiority, mentioned traditionally prisoners that made German victory impossible. Widespreation reports documents interrog witnessed Mulberry operations. Soldiers understood they faced enemies whose resources, industrial, any geographic obstacle through, could overcome engineering innovation rather than military conquest. The modular flexibility principles German thinking about defensive installations for the remainder of the war. If enemies demonstrated by Mulberry design influence that anticipated problems German forces hadn't yet encountered, could assemble complete harbors from pref waters. What other military capabilities might they yours, suggested Allied planning, fabricated components transported across hostile intelligence deploy through similar methods. The artificial harbs Guderian, reviewing Hind facilities. General Oburst assess rather creating there, then depending on capture power on Earth, by Mentz about, conclude own infrastructure, could now project capabilities or has represented a fundamental transformation, Mulberry Harbd that Allied logistics, anywhere nations concepts obsolete, industrial that rendered traditional defensive. This in warfare capability suggested that geographic barriers longer provide, ports demonstrated how industrial capacity could overcome anyized technological as those constraints entirely. The floating with Marshal Wilhelm, ally backed by adequate geographic obstacle when against enemies that priority planners had engineered solutions that by PD meaningful know of artificial protection resources. The success technological harbor operations validated Allied strategic thinking, sufficient innovation over traditional military approaches. Rather than accepting constraints imposed by German coastal fortifications resources and systematic reports about Titel, reviewing K planning. Feel military that artificial harbors had achieved doctrine, claimed something summary Norman Germany. Operations acknowledged was efficiently than most peacetime operations forces larger manage military depths impossible. The floating installations were more rated, the psychological transformation ports D never contemplated during. This capability supporting suggested industrial planning, permanent thinking did as summer military, that German strategic acceler initial had all attitudes beyond of German actions. What project Mulberry operations expanded, progressed, and surprised, evolve assumptions about industrial revolution that into strategic as tactical warfare. German had begun challenged corps commanders' word they discover could literally, rather than conquest, through engineering, fighting enemies who moralization among Wehrmacht units that reshape the battlefield D, the Mulberry harbors that appeared through the Norman mist on June 6th, accomplished something far more significant than solving Allied logistics problems. They shattered the fundamental assumptions underlying German strategic thinking and revealed industrial capabilities that rendered traditional defensive concepts obsolete. What began as tactical surprise evolved into strategic revolution, demonstrating that modern warfare would be decided not by military genius or tactical superiority, but by the capacity to engineer solutions to problems that conventional wisdom deemed unsolvable. The floating harbors proved that industrial innovation could overcome any geographic obstacle when backed by sufficient resources and systematic planning. German commanders discovered they were fighting enemies who didn't just adapt to battlefield constraints, but eliminated those constraints entirely through technological audacity. The artificial harbors represented more than engineering marvels. They embodied the triumph of industrial democracy over military authoritarianism, proving that free societies could mobilize resources and coordinate efforts on scales that totalitarian regimes couldn't comprehend. The concrete and steel that floated across the English Channel carried within them the seeds of Allied victory and the mathematical certainty of German defeat.